Alright guys, this is the warm-up for today. Give it a shot. Remember, exact values come off the unit circle, so everyone should have out their unit circles today. Please push pause and give them like 3 minutes to complete this. Okay. Just kind of reminding everyone how to find these values. This right here is just saying cosine of 2 pi over 3. So you come over here to 2 pi over 3, and cosine is the x value, so your answer is -1/2. Tangent. Okay, tangent of -pi over 6. Now remember, negatives go down, so I'm actually right here. And tangent is y over x. Okay, so that's going to give you, see if I can get my hand out of the way, -1/2 over square root of 3 over 2. Okay, whenever you reduce that, you get negative square root of 3 over 3. I'm going to have to practice this. Okay, sine of -5 pi over 3. Well, I know the regular 5 pi over 3 is down here. And if you remember, the negative version is just straight up from it, so it's right here. Okay, so I'm looking at these two. And sine is the y value, so it's just square root of 3 over 2. Okay, the whole purpose of that warm-up was to kind of get you guys used to normal functions, normal trig functions, and because today we are actually going to be starting inverses. Now we're just going to do sine and cosine, and we're going to look at their graphs today, because today is a half day. So we're kind of stressed for time. First things first, though. I need you guys to actually understand this, that sine and cosecant are reciprocal functions, okay, which look like this. This is not the same thing as an inverse. Okay, I know I've been saying that for a little while, but I need to make sure everyone understands this. Just kind of remember that inverse functions have domain and range values reversed. So in other words, you're switching your input with your output. You're switching your x with your y. Okay? Alright, the first thing we're going to do is we are going to be looking at a cosine graph. So what I want you to do real fast, and I'm going to give you about a minute, go ahead and draw the regular cosine graph. Just kind of sketch it really fast. Doesn't have to be pretty, just the parent function. Okay, and please push pause and allow them to actually draw this graph. It should only take them about 1 to 2 minutes. Okay, welcome back. This is what your cosine graph should look like. Okay, the amplitude of 1 kind of goes up 1 and down 1, right? Okay, so it's just like the unit circle. Now, just to kind of make sure everyone understands this, do you remember back when we were doing the inverse unit? We were talking about how you can tell that if an inverse would be a function or not. And it would be a function if it passes the horizontal line test. Well, if you kind of look at this function right here, would we pass the horizontal line test? And the answer is no. It actually crosses many, many times because it keeps going on forever in both directions, right? So they had to actually make restrictions for your inverse to actually make it a function. Okay? And now they made the restrictions as close to the y-axis as possible so that it would actually be easy to read the angles and everything. Okay? So what they have done is they came over here and said, we need to make this thing pass the horizontal line test so I can make a function. So they cut this graph right here and right here. Okay, so between 0 and pi. They actually cut this graph into sections so that none of this other stuff outside of this box, so over here, none of that is actually there anymore. Okay, so I know that's kind of hard to understand. They cut this graph so that it would now pass the horizontal line test. So your inverse actually only covers this little section. Okay, from 0 to pi. And that's actually very important to know. It goes from 0 to pi. Okay? Alright, let's kind of move on with our notes. Okay, so what we're going to actually do is we're just going to kind of state domain and ranges real fast so everyone kind of understands. Let me turn this over so no one gets confused. There we go. Okay. So I know, and yes, there is no difference between a lowercase c and a capital C. Okay, cosine is cosine no matter what. I'm just doing this to kind of show you the difference of what we have done. This one right here is going to be your normal cosine curve. Okay, so domain and range. And we know those domain and ranges. The domain is all real numbers, right? And the range goes from -1 to 1, right? That's the normal curve. Okay? What I want to do right now is actually make a domain and range for that restricted area that we just did. Okay, so only the restricted area, that middle section, okay? So the domain for that is actually only from 0 to pi, and we kind of talked about that, okay? Well, the range for that restricted area is the same as the other range, right? It only goes from -1 to 1, okay? Now, we are going to be taking our inverse based on this middle graph right here, okay? So I know that an inverse technically switches my range and domain, okay, because it switches your input with your output. So now your domain for your inverse is going to be -1 to 1, okay? And your domain is going to be 0 to pi. Now this is kind of weird looking because now I have my angles on the y-axis and my values on my x-axis because we've actually switched them. So we have to be careful. Alright, so what does this mean to us? This means that the inverse cosine can only produce angle measures in quadrants 1 and 2. Okay? You are restricted on where you can actually go on the unit circle. So kind of think about what we have done here. Okay? We have this unit circle. Alright? And we have axis, just like this. That's our unit circle. And I'm restricting my graph to 0 degrees, so right here, to pi, which is right there. So only this section. Right? And since we've restricted it, we've actually completely gotten rid of the bottom of the circle, like it no longer exists. That's what a restriction is. We have cut this circle in half, so it's no longer there. Okay, it's very, very important to actually understand this. You can only go from 0 to pi with an inverse of cosine. Alright, and that's going to make a little bit more sense in a minute. Let's actually, let's actually draw the graph of an inverse cosine graph, okay? And it's going to be based off of that graph that we just did, okay? This little inverse section right here, alright? So the first thing that we need to do, I'm just kind of moving this down so I have space, okay? We need to kind of draw a little graph right here, alright? Now, instead of, angles on my x-axis, I have values. And I know that range, well, it's the domain now, right? It goes from -1 to 1. Okay? And the range is now from 0 to pi. right? Okay, so at what angle are we at when we are at 0 degrees? I mean, not what value are we at when we are at 0 degrees? For cosine, we are at 1, so it's over here. Okay? Sorry about that. Someone walked in and started talking to me. Okay, so we are at 1 over here. Well, we don't normally jump from 0 to pi, right? There's actually a spot in between that. It's, what is that? That is pi over 2, correct? Okay, and I know cosine at pi over 2 is 0. So I have a point right there. And then I know that cosine at pi is actually negative 1, so it's right there. Okay? And let's see if I can draw this. Good. Curves in like this. Just like that. Did I do that good? Yeah. Okay. So you can kind of tell if this was continued to kind of come down this way, it would actually make a cosine curve. We've just kind of restricted it off to that little section. Alright, so that is what the cosine graph looks like. Let's do sine. Now I'm going to move a little bit faster now since we've already done one. Okay. Sine. Take just a second, draw the sine graph. Okay, you probably should be able to keep up with me now. Okay. We have a 1 and a negative 1. Okay. Starts in the middle and goes up, back down. Looks like that, right? There's the positive one, and then it's going to continue to do the same thing. So down, middle, up, middle, just like this. Okay, so that is our sine graph, right? And same kind of thing, obviously this is a wave and it does not pass the horizontal line test. So we need to make restrictions. Now we want to make the restrictions as close to the y-axis as possible. Okay, just for simplicity. Okay? And they actually decided to cut it right here whenever they were finding the restrictions for the first time. Okay? And you can tell that this middle section would pass the horizontal line test. Now remember, when we make these restrictions, everything outside of these lines now, okay, so everything out here, do not exist anymore, right? Because we need it to pass the horizontal line test. That's very key. Alright? So what angles are we actually between now for sine? Negative pi over 2 to pi over 2. So what quadrants does that actually cover, that little span? Okay, so let's kind of think about that. We have the circle again. Okay, positive pi over 2 is this little section, so I know it covers the first quadrant, right? Okay, but negative pi over 2 is down here like this, so it's actually covering the fourth quadrant down here. Now, what we've done is we've cut this section of the circle, like, completely gone, right? That section is not there anymore. So we have to be very, very careful because we can no longer go around the circle, right? Because it's gone for inverses. Remember, for regular functions, you can go all the way around. But for inverses, it's only half the circle. That's something that we have to remember. In inverse, it's only half the circle because we had to set restrictions to make it a function. Alright? So let's go ahead and do that same kind of process. Let's run through these domain and ranges real fast of this. Okay, and then we're going to look back at the graph. Okay, domain and range of a regular sine function, all real numbers. Domain and range of, the range is -1 to 1. Getting tongue-tied. Okay, the restricted version, remember the capital S and lowercase s is just for us to symbolize that this is the restriction. Okay, and you can even write restricted up here, okay? So you remember. So the domain is from -π/2 to π/2. It's like this. And the range is the same, okay, right? It's -1 to 1. Okay, that didn't change. Okay, the inverse is just the switch of this. This is the reason why we had to do this. Alright, so it goes from -1 to 1, and then the range is -π/2 to π/2. Just like that. Alright, so let's actually do this graph now. Now remember, we have switched axis because it's an inverse. So my 1 and -1 are now on the x-axis. It's the domain now, right? Okay, and my range goes from π/2 to -π/2, right? And then our center point on this one is going to be 0. We don't have to actually add it in. Okay? So kind of think about at -π/2, where is sine at? So remember, sine is the y value. I'm looking at my unit circle. That's straight down. My son is talking. Can I turn this thing on? Okay, sorry, that's my baby monitor. Okay, so over here, so it should be right there at -1, bottom of the circle, right? -π/2, bottom of the circle. That point's a little off, but you get the idea, okay? At 0 degrees, or 0 radians, sine is at 0. And at π/2, it's at 1. So it kind of looks like that. Okay? Now remember, you're kind of curving to your points, right? So it looks just like that. Okay, everyone got it? Now the key thing to remember is what quadrants you can actually go into. It is the first and fourth quadrant. Alright? That's very, very key. Okay, which kind of says it right there. This means that the inverse of sine can only be produced angles in the first and fourth quadrants. We must use the negative angle measurements in quadrant 4 because we can't go through that circle anymore, because remember, we cut it in half. The left side of our unit circle does not exist anymore, so we have to actually go down to get to the fourth quadrant, which means that it is a negative angle down there, so be very careful. Okay? And let's see. This stuff right here is for Monday. So we are done for the day. Okay? Enjoy your weekend, guys. Should be a fun one. And I will see you on Monday.